See here, the previous session, we clearly discussed how can we create linear single linked list. How can we create the linear single linked list? So this linear single linked list we created. Okay. In today's session, I want to talk about how can we insert a node in the linear single linked list. How can we insert a node in the linear single linked list? So topic name is inserting a node in linear single linked list. Okay, inserting a node in linear single linked list, inserting a node in linear single linked list. So how can we insert the node in linear single linked list? So this part I want to talk in today's session. Okay, so already linked list is created. Okay, so to create the linked list, in the previous session we have written the program. I'm opening that program. Observe. So in our folder, linked list one program is there. I'm opening that one. Observe here. So we created one node type. Okay. So we created one node type here, one node class. Then we defined linked list class here. In the linked list class, we defined add method to add a new node, and we defined show method. We defined a show method to print all linked list elements. Okay, now I want to insert linked list is created. Linked list is created with 5 elements. I'm running this program. Observe. So it is printing linked list elements. So 5 elements are there in the linked list. In the linked list, 5 elements are there. In the linked list, 5 elements are there. See, these are the 5 elements. Now my program is, now my task is, I want to insert a node in the linked list. I want to insert a node in the linked list. Okay. So for this, I want to define a method with the name. I want to define a method with the name insert. So where we want to insert, we have to specify that one. So that is called position. So we must specify the position and which element, which value we want to insert. So take two arguments here. So one is position and another one is what? Value. Here we are capturing position and value. So here linked list is already created. In the linked list, observe here, in the linked list. So this is first position. This one is second position. This one is third position. This one is fourth position, and this one is fifth position. So at which position you want to insert the node? At first position, or last position, or in the middle? That we have to specify. So position number 1 means first position. Okay. Position number 2 means here at second position. Position number 3 means here at third position. Position number 4 means here at fourth position. Okay, at which position we want to insert the element, that one we have to specify. So for that, I'm to capture the position value. To capture the position value, I'm taking p variable here. So p means position into v. So which value, which value you want to insert? That new value. That new value we are passing. So position and value, both are we are passing. So now we have to create a new node now. So we have to create a new node. I'm assuming that new node as temp. So temp equals to new node. Now new node will be created. Now with this code, temp equals to new node means with this code, what happens here? A new node will be created. Okay. So here one new node will be created. I'm dragging that one. Observe. Here a new node will be created. This new node will be created. Okay. Memory will be allocated for the node. Okay, in this, to hold x value, some memory allocated. To hold the next value, some memory allocated. Okay, so this node's name is what now? This node's name is temp. This node's address is in the temp. So temp node is created. Okay, here 3 cases are there. So one temp node will be created. Okay, so what is the temp x value? What is the temp x value? See here, temp x equals to v. So when we call insert method, we call like this. We call like, okay, L1 object name dot insert. At which position we want to insert? For example, I want to insert at first position. I want to insert a new element 100. So 1 comma 100 like this we pause. We call. Okay. For example, I want to insert at fourth position. So what we write? L1 dot insert of at fourth position. I want to insert the new element 200. So like this, we are calling the insert method. First one is position value. Next one is where we want which value, new value. This is the element, new value. This is a position. So at fourth position, I want to insert the new element 200. At first position, I want to insert the new element 100. So to capture the position value, I'm declaring p variable here. To capture the value, I'm taking v variable here. So temp x equals to v. Okay, now we have to check here three cases are there. Here total three cases are there. What are those three cases? Observe. Total three cases are there for insertion. What are those? First one is inserting at first position. Inserting at first position. Inserting at first position. Second one is inserting node at last position. Inserting at last position. Inserting at first position. Inserting at last position. Inserting at last position. Okay. Inserting in the middle. Inserting in the middle. So total how many cases are there? Three cases are there. Inserting at first position means here. Here I want to insert the node at this position. So before 10, I want to insert a new node. First position. This is the first case. Another case is I want to insert here. After 50, I want to insert a new node here. Here I want to insert. Okay. So at first position I want to insert, that is one case. At last position I want to insert, or otherwise I want to insert at fourth position here. Here I want to insert in the middle, or in the third position I want to insert here in the third position. So like this. So here only three cases are there. We want to insert at first position or last position or in the middle of the linked list. Okay. So if we give position value as 1, okay, now here we have to check whether we want to insert at first position or not. So for that, if position value is equals to 1, this condition true means we are inserting at which position now? First position. We are inserting the node at first position now. Okay. So if position value 1 means we are inserting at first position. If we are inserting at first position, which code we have to execute? Observe here. So now this is the new temp node created. This node I want to insert at first position. Okay. So temp we are calling like this. We are calling like observe. We are calling L1 dot insert of, I'm giving position value as 1 and new value as v value as 100. So if position equals to 1, 1 equals to 1, condition true. So here temp node already created, temp x equals to v. So what is the v value now? V value is 100. What is the v value now? V value is 100 now. What is the v value? V value is 100. So temp x equals to v means this temp x value will become 100. So this value will become 100 now. This value is 100. Okay. Now here we are checking whether the position is 1 or not. Here we are checking whether the position is 1 or not. So position is 1. Okay. So p value is 1. 1 equals to 1. Condition is true. So when this condition is true, what we have to do is observe. See. So now we have to establish this relationship. Okay. I'm showing clearly. Observe carefully here. Just a minute. Okay. See here. So now we have to establish a link like this. We have to establish this link. We have to establish link like this. Okay. So to establish link like this, okay, means what? This first this temp next holds address of next node. So this first should become next node of the temp. This first should become next node of the temp. So what we have to write? Temp next equals to first. So what we have to write? Temp next equals to first. So here I'm writing temp next equals to first. So temp next equals to first. So with this statement, what happens? First node's address will come into the temp next. First node's address will come into the temp next. So here, observe. Okay, observe here. So with this code, with first node's address will come into the temp next. So here this is first node. This first node's address will come into the temp next. So here that address will be stored. So this relationship will be established now. Now this one is the not first node. Temp should become the first node. Now temp should become the first node. Temp should become the first node. So to make temp as the first node, to make temp as a, now this temp should become the, sorry, this is not first now. This temp should become the first now. Temp should become first. So to make temp as first, which code we write? First equals to temp. Okay, so temp address will come into the first now. So now temp will become first node. That's it. Once again, I am repeating. Pay attention and listen carefully here. So here we want to insert a new node. To insert a new node, we are defining a new method, insert method. Okay, so we are taking two arguments here. P means position, at which position we want to insert, which value we want to insert. P means position, V means value. Temp equals to new node means a new node will be created. A new node will be created with X and next. So a new node will be created with X and next. Just a minute. Just a minute. So a new node will be created. That is what? That is temp. A new node is created. Temp X equals to V. What is the V value? 100. So temp X equals to V. 100 value will be stored. Next, it checks whether position value is 1 or not. So now position value we have given as 1. Yes. So condition is true. So temp next equals to first, means this first node's address will come into the temp next. So this relationship will be established. This link will be established. So temp next first becomes temp next. Okay, now this one is not first. This temp should become the first because we are inserting at first position. So this temp should become first. So that's why we are writing first equals to temp. So now temp becomes the first. So temp node's address will come into the first. Means this temp becomes the first now. So hence we can insert the node at first position. So one case is over. One case is over. Now see another case. Observe. Else. Okay, I'm writing else here. Else part. So when that comes to this else part, okay, if we are not giving position value as 1, if we don't want to insert the node at 1, so if this position value is not 1, okay, that comes to this else block. If position value is 1, that executes this code. If position value is not 1, that comes to else part. That comes to the else part. Okay, that comes to the else part. Now listen carefully. Okay, listen carefully here. Now, for example, I am giving position value as, this is the linked list. This is the linked list. Just a minute, please wait. Just a minute. See here. So in this one is the first. This one is the first. And this node is the last. This one is the last. Okay, so this one is the first node, this one is the last node. Okay, now for example, I am giving position values. See, okay, this is position 1, position 1, position 2, position 3, position 4, position 5, position 6. So at last position means position 6. At last position, I want to insert a new node. At last position here, I want to insert a new node. So for that, I'm calling as okay, L1 dot insert of, I'm giving position value as 6 and I'm giving value as 100. So at 6th position, I want to insert a new node with 100. Okay, so now that checks the position value here. What is the P value now? P value is 6. P value is 6. So this condition false, that comes to the else block. What is the V value? V value is 100. Okay. So now we are not inserting at first position. So if we are not inserting at first position, that has to execute this code. See here. So now what we have to do is assume that this first node as uh, pointer. I'm assuming this as a pointer. So which code we write now? Pointer equals to first we write. So pointer equals to first. Pointer equals to first. So first node's address will come into the pointer. Now this one is the pointer. So we want to insert at sixth position. So means we have to come till here. We have to come till this 50. So now we are at 10. Now we are at 10. Okay, we want to come up to 50. So now if this is the pointer, this is what pointer next. If this is pointer, this is what this pointer next. So first one is the pointer. So this one is what? Pointer next. Next time this pointer next should become the pointer. This pointer next should become the pointer. Okay. So to make pointer next as the pointer, we write like this. We write pointer equals to pointer next. We write pointer equals to pointer next. So this pointer next will become the pointer now. So this second node's address will come into the pointer. Okay. Now this one is not pointer. Now this one is not pointer. This one is the pointer. Okay. Now this one is pointer next. Not this one is not pointer next. If this is pointer, now this one is the pointer next. Now this one is the pointer next. So next time this pointer next should become the pointer. Again we have to execute the same code. Now this one will become the pointer. Okay. Now this one is not pointer. This one is the pointer. This one is pointer means this one is not pointer next. Now this one will become the pointer next. Now this one will become the pointer next. Okay. Now this one is pointer. This one is pointer next. Next time this pointer next I want to make as pointer. So this pointer next I'm making as pointer means now this one is not pointer. This one is not pointer. This one is the pointer. Now this one is not pointer next. This one is the pointer next now. Now this one is the pointer next. This one is the pointer next. This one is pointer. This one is pointer next. I want to make this pointer next as the pointer. Okay. So write this statement. Pointer equals to pointer next. Okay. So now this one is not pointer. This pointer next will become the pointer now. This pointer next will become the pointer. Okay. Now this one is not pointer next. Okay. So we have to come till here. So now we have to come till here. Okay. So if you want to insert a node at sixth position, we have to come till fifth position. Okay. So for that, we are assuming this first one as pointer. So next this pointer next should become pointer. So next time this is the pointer. 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 Now this one is the pointer. So we want to insert a sixth position. So we came up to fifth position. So to came up to fifth position, we are assuming first node as the pointer. So next time this second node we are assuming as pointer. Pointer next is becoming the pointer. Next pointer next is becoming the pointer. Next this pointer next is becoming the pointer. Next this pointer next is becoming the pointer. So now this one is the pointer. Now we have to check whether this is the last node or not. If this one is the pointer, this one is x. This one is what? Next. This one is x. This one is next. Okay. So if pointer next equals to null, means we want to insert at last position. Pointer next equals to null means what? We want to insert at last position. So now check the condition here. If pointer next equals to null, then we want to insert at last position. Okay, here three cases are there. Whether we are inserting at first position or last position or in the middle. In the first position, very simple. If p value is 1, we are inserting at first position. Okay, if p value is not 1, assume first one as the pointer. So next, this pointer next will become the pointer. Pointer next will become the pointer. So like that, we have to go up to position minus 1. So if position value is 6, up to the 5, we have to go. Okay, so for that, first time we are assuming first one as the pointer. So next time pointer next is becoming the pointer. This pointer next is becoming the pointer. Next time pointer next is becoming the pointer. Pointer next is becoming the pointer. Pointer next is becoming the pointer. So this pointer next is becoming pointer for how many times? For how many times? 4 times. So I want to execute this statement for 4 times now. I want to execute this statement for how many times? 4 times. So if position value is 6, we have to execute for 4 times. 4 times. Okay. If position value is 4, if position value is 4, okay, we have to execute for 2 times. We have to execute this statement for 2 times. So it means for position minus 2 times, we will have to execute. How many times we have to execute now? Position minus 2 times. Okay, in this example, we are giving position value as 6. Here we are giving position value as 6. So if position value is 6, this pointer next should become pointer. 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 This code we have to execute for 4 times. Means p minus 2 times I want to execute. So that code I'm writing here. So here, write, assume that. So take one node pointer variable, node pointer. So we are assuming pointer equals to first. So now first one is the pointer. Okay, how many times we want to execute now? P minus 2 times. So for int I equals to 1, I less than or equals to p minus 2. P minus 2 times. Which code we want to execute? Pointer equals to pointer. Next code we want to execute for p minus 2 times. Okay, just now I explained very clearly. Okay, see, first time, this first is the pointer. I'm showing, once again I'm explaining. Observe. Just a minute. Just a minute. Observe here. So here, what we are writing, node equals to pointer, we are declaring. After that, pointer equals to first. So this first is becoming the pointer. Next time, pointer next will become pointer. Next time, again, if this statement executes again, pointer next will become pointer. So like that, how many times we are executing now? P minus 2 times. In this example, position value is 6. So when position value is 6, 4 times I want to execute now. 4 times. 4 times, pointer next should become pointer. Okay, so to execute, so if position value is 6, 4 times it has to execute. If position value is p minus 2 times I want to execute now. So that's why we are writing this logic. So p minus 2 times this pointer next will become the pointer. Okay, now check whether pointer next value is null or not. Okay, now this one is the pointer. So we are coming till here. Now this one is the pointer. So pointer next became the pointer for 4 times. So now this one is the pointer. So this one is pointer x, this one is pointer next. So now what is the pointer next value? Null. Pointer next value null means this is what? Last node. Pointer next value null means this is last node. So if this is last node, okay, so we have to create a node here. One temp node will be created here. One temp node will be created here. This temp node will be created. This is the temp node. This is the temp node. Just a minute. Let me draw. So this is a temp node. This is the temp node. Just a minute. This one is the temp. Temp node is created. Temp node is created. Okay. So this one is temp x. This one is temp x. This one is temp next. So now what is the temp x value we have given? 100. Temp x value we have given as 100. Okay. Temp next we have to establish. Okay. Now observe carefully. Listen carefully here. Listen carefully. Now we want to insert at which position? Last position. We want to insert this node at last position. Okay. So observe carefully here. So this node we want to insert at last position now. here. So for that, we are establishing relationship like this. So now we have to establish a relationship like this. Just a minute. We have to establish this relationship. This relationship we have to establish. So temp should become last next. So what we have to write now? Okay, last next equals to temp. Last next equals to temp. So what is the temp next value? So this should become the last node, right? After this, no node is there. So temp next equals to null. Last next equals to temp. This is the code we have to write. So that's why I'm writing. So temp next equals to what? Null. So here write temp next equals to null. So after temp, no node is there. So temp next value should become null because this is the last node. Okay. And last next equals to last next or pointer next. Pointer next equals to pointer next equals to temp. Pointer next equals to temp. Okay. So now what happens here? Now we are coming till here. Now this is the pointer. Now this one is pointer means this is what pointer next. This one is the pointer next. So pointer next should become this temp should become pointer next. This one should become pointer next. This temp should become pointer next. So right pointer next equals to temp. Now this value is not null. This has address now. Now this value is not null. This has temp node's address. So temp node's address is coming into the pointer next. So this link will be established. This link will be established. So pointer next equals to temp means this link will be established. So temp node's address will come into the last next. So temp will become last next. Sorry, pointer next. This last pointer both are representing same. So pointer next is becoming temp. Now this temp should become last node. Now this temp should become last node. Okay, so write last equals to temp. Right, last equals to temp. That's it. So write last equals to temp. This is the code. Okay, so if you want to insert at last position, this code will get executed. This code will get executed. So temp next equals to null. So after temp, no node is there. So temp next should become null. So pointer next equals to temp. Okay, so we are coming first time. This first is the pointer. So we are coming till here means this last node is the pointer now. So pointer next value null. So pointer next equals to temp means the temp node's address will come into the pointer next. So this link will be established. So next time temp should become last. So last equals to temp we are writing. So if you want to insert at first position, this code has to be executed. If you want to insert at last position, this code has to be executed. Another case, third case and last case, if you want to insert in the middle, if you want to insert the node in the middle, okay, so temp node should be created. For example, I want to insert at fourth position. I want to insert the node at fourth position. Okay, just a minute. I'm closing this and I'm opening just a minute. See here. I'm opening with paint. See, observe. So just now we have seen if we insert first position, what is the code? If we insert the node at last position, what is the code? Now I want to insert the node at fourth position. So we have to create a temp node. So like this, a temp node will be created. Okay, this node I want to insert at fourth position. At fourth position means here. At 40th position, I want to get 100. After 30, I want to get 100. So at fourth position, I want to insert a new node. So this is the temp node. This temp node I want to create now. So this is the temp node I want to create. So if here this one is the X, this one is the next. So this temp node we have to create. So write temp X equals to V. Okay. So here what is the V value? 100. So temp X equals to V. So temp equals to new node means new node is created. Temp x equals to v means v value will come into the temp x. So now this temp x value will become 100. This temp x value will become 100 now. Okay. Now this node I want to insert at third position. So this is the fourth position. This is the first position. This is the second position. This is the third position. After third position means here I want to insert 100. Okay, means till here we have to come. So we are giving position value 4 means till position 3 we have to come. So now this one is what? This one is the first. Now this one is what? This one is the last. So assume first one as the pointer. Assume first one as the pointer. So now this one is the pointer. So next time this pointer next should become the pointer. Now this is the pointer next. This pointer next should become pointer. So this next time this now this is pointer. This one is the pointer next. Next time this pointer next should become pointer. This pointer next should become pointer. So now this one is the pointer. So till here we have to come. So this pointer equals to pointer next statement. Pointer equals to pointer next statement has to be executed for how many times now? This statement has to be executed for 2 times because we are giving position value as 4. We are giving position value as 4. So if position value is 4, 2 times, so that has to execute. So this pointer next should become pointer. Next time this pointer next should become pointer. Now this one is a pointer. These are not pointers. No. Now this one is not pointer. Now this one is not pointer. This one is a pointer. Now this one is a pointer. This one is a temp. So we have to insert this node here at fourth position. So very simple. What we have to do is we have to establish. Just a minute. We have to establish this relationship. Just a minute. So we have to establish this relationship. This relationship and this relationship. Okay. Now a new node will be inserted. Observe. So temp next should become, this one is a pointer, right? This one is pointer means this one is what? Pointer next. So temp next should become pointer next. So temp next should become pointer next. So for that I'm writing temp next should become pointer next. So I'm minimizing this. Temp next. So temp next should become pointer next. So pointer next is becoming the temp next. Okay. So this link is established. So this link is established. Okay. Okay, so what we have written, temp next equals to pointer next. So this pointer next's address is coming into the temp next. So this pointer next is becoming temp next. Okay, so this link established. Now this one is a pointer, this one is a temp. So pointer next should become temp. So right, pointer next equals to temp. So right, pointer next equals to temp. Right here, pointer next equals to temp. Pointer next equals to temp. That's it. Okay, now link established. This link will be established. So pointer next equals to temp means this temp node's address will come into the pointer next. So now this link will be gone. This link is not there. So hence we can insert the node. So very simple. So here we are inserting a new node. So for that we are creating temp node. We are establishing this relationship and this relationship. That's it. We're establishing this link and this link. That's it. Okay. Now I'm copying this code. So here, what is the return type? Return type is white. This is not returning any value. So I'm copying this method. Okay, list time is there. And I'm pasting in our program. So in our program, I'm pasting it. Observe. Here I'm pasting. I'm adding the method, insert method. So here, insert method code we have written. I pasted here. Insert method code. This is insert method code. Insert method code. Okay. So now I want to insert a node at first position. So L1 dot insert, L1 dot insert. Okay. At which position we want to insert? At first position. I'm giving 100. Observe here. I'm running it by pressing F11. Observe. Just a minute. Oh, so we have to print. We have to print the elements. Okay, so now the elements are what? 10, 20, 30, 40, 50. Okay, now I want to print the elements. Observe L1 dot show. At first position we are inserting. Now observe after inserting what are the elements. Observe after inserting elements, or see here. So for the show method, I'm changing the line. For the show method, I'm changing the line after printing all elements. I want to change the line. So I'm writing cout /n/. For our understanding purpose, I'm changing line for 2 times. Okay, now observe. At first position, one node inserted. Observe here, at first position, 100 inserted. Okay, here we are inserting element at first position. Now I want to insert element at last position. So last position where number is what? 6. 6 I am giving. Observe. Observe at 6th position 100 is inserted. Okay. Now I am giving position value as 4. Observe. Okay, at 4th position 100 is inserted. Hence we can insert the node in the linked list. Now I'm stopping the session here. I'm stopping the session regarding today's session.